And I'll start sharing screen and clean this little thing up here. So last time I think we ended with the spring joint, a joint that makes a springy thing between things. And we had bouncy objects that we could have kind of on the end of a spring. Somebody need something? No? Okay. So one of the examples that I did with the spring joint was the drag rigid body. And this is a script that's available from standard assets in the utilities folder. Basically, I went through my version of it that has these public variables. It has these various update or bailouts from the update function, the function that's called every frame. And it had an example of making a game object on the fly. So this made a new game object called rigid body dragger. It added components to it. It added a rigid body and a spring joint. It modified those properties, setting the is kinematic to true. And then it threw raycasts out to find an object that it had hit. It connected the spring joint to the hit point and did various magic involving this coroutine, which we'll talk about much later, where we caught the drag of the old object because we wanted to set it to our values. And then watching the mouse button, we moved the object around. And when we were done, we put it back the way it was and disconnected the object. And so we then had the ability to pick up different objects, move them around, fling them through the scene. And I mentioned that modification of the standard asset drag rigid body, which is not strong enough to pick up something that's heavy. The modification was that you scaled the spring and damper by the mass of the object that you were trying to pick up. And that made it that gave it the ability to pick up these heavy objects. So moving on to the next joint, the character joint. And the character joint is a funny one. It acts like a ball and socket joint. And you have three axes. The dominant axis is sometimes called the twist. And the way to think of this is a shoulder. The twist axis is the rotation of the arm. And then we have our first and second swing axes. First would be up and down, and second would be forward and back. So these kind of joints are a little bit funny, and I spent an inordinate amount of time here trying to set up a character joint that mimicked an arm. And so I've got this little character that rotates around, and I've built this little shoulder structure. And it's hard. The characteristics of this character joint are difficult to manipulate. The settings for it are somewhat complex. We have the dominant axis that we specify with a vector. Here I'm making it in the Y direction. And then we have the second axis, the swing axis, that I've put in the Z direction. And then the third axis is automatically perpendicular to those two. And then we have limits for the twist, upper and lower limits. And we have swing limits that go from plus or minus values. Now, the easiest way to figure out how this thing works is to fiddle with it. And so you can make these changes here while the thing is running, while the game is running and it's paused, well, while it's running, and you can make changes here and see what they look like. Now, one thing I don't know if I've mentioned is that any change you make in an inspector while the game is running, when you stop the game running, it reverts. So these things, these changes that you make while the game is running are not permanent. Here's a trick. When you find some configuration that you like, you can pull down a copy component command, and then when you stop it, it'll go back to what it was originally, but you can paste component values in, and all of those changes that you made will be captured and stored back into the scene. So the character joint is very fiddly, but there's a much easier way to deal with it, and that's with the ragdoll. So here's a ragdoll. Here's a ragdoll, and I'm showing it here in the wireframe so that you can see all the different pieces of the ragdoll. And the ragdoll has is put together with compound colliders, and those colliders are all connected to each other with character joints. If I go down through the hierarchy here, I think I can find some of the joints. So where's a joint? There, a character joint that is connecting the left hip to the root, and it has various settings that make this look physically realistic as a ragdoll character, a character that we can pick up with our drag and fling around, and its joints are configured in such a way that it has kind of a realistic humanoid form. And of course, setting one of these up yourself would be extremely tedious, but there's a tool in Unity for making ragdolls. Where's my ragdoll? So here in this scene, first of all, this character scene that I'm showing you has half a dozen or more characters that I've found in various free assets, and I've ripped them out so that I can use them. I have a gladiator, a soldier, a robot, 3 guys, Vincent, Justin, and Carl, 3 women, Mia, Joan, and Alexis, and Mr. Gray, the alien, and the wizard. And these are all fully wired up characters, and I'll show you later how to animate them. But for the time being, I want to just make a ragdoll. I've already made one of Carl here. Here's Carl, Carl's ragdoll. And oh, there's an example of the drag rigid body not being strong enough to pick it up. So here I've modified that drag rigid body, and I have the uniform switch on. So now now it'll be strong enough to pick up Carl, because it's scaling the spring constant by,
James.
Wait, you have a question?
What was that?
You have a question? No.
James, that's what she said. And you know what?
Hey, Owen B, you're the one talking.
All right, back to the unless there's a question, I'm going to continue on here.
I think he
So-
accidentally muted his mic.
Let's make a ragdoll, and I've got a scene here with Robot Kyle in. I'll save that scene. And Robot Kyle came from its prefab. Its prefab is over here in the characters folder model. This is an FBX prefab that has various stuff that we'll talk about. All I did was drag and drop this into the scene. Now, because I'm going to modify this, one thing I might do here is unpack the prefab. So this is going to disconnect it from its prefab over here. So it's no longer a little blue thing. It's now black. It's no longer connected. Another really important thing to do before you start to make the prefab is to take the animator off. Get rid of the animator. This ensures that the character's in T-pose. The robot doesn't look very T, but this puts him in T-pose. Now, I'm going to be expanding the tree that is my little character here, because I'm going to be connecting various pieces in the tool that makes a ragdoll, 3D object ragdoll. And this now opens a little window where I have to assign each of these different pieces. And the pelvis is usually the top object here, the root of this thing. So I'll put the pelvis in here. And now I have to go down through here and find the different components here. And so this often involves a little bit of guesswork, but I'll put left thigh in here and right thigh in for right hip. And I'll put left knee in for left knee and right knee in for right knee. And now I have to find the foot. And I'm going to guess that it's just this ankle joint because I don't think I want the toes. And again, this does involve some guesswork as to the different naming pieces. Now I've got to go up and find the arm. Here's the right shoulder and left shoulder. I'm going to guess upper arm here and right upper arm. And then I'm going to go down one more level here and find the left forearm, and I'm going to guess that's the elbow. And that's the elbow. The middle spine is one of these three objects that this is connected to, root, hip, and ribs. I'm just going to guess the ribs here. How this turns out is different depending how you guess. But you can do this many times here and get it all right. So we filled in all these different pieces. You can set a mass. The strength doesn't seem to matter. I don't know what flip forward does, but when you're all done, we create. And we now have a ragdoll. If we look at this character, we can see now that it's built this set of compound colliders. There are all these different colliders here that that make up its different pieces, and they're all connected together with character joints. And now my little Kyle is going to fall nicely, and I can pick him up and fling him around, and he behaves exactly the way a limp humanoid body would behave. So this is a one-shot deal. You can't go back and edit these things. Well, you can if you really want to fiddle, but in general, you're going to have to repeat the process. If pieces don't match up and your character behaves in a weird way, you may just have to start over again. So remove the animation component, put it in T-pose, probably disconnected from its prefab, open the ragdoll window, insert all the different pieces, create, and maybe save this as a prefab for use later. Now, one of the things that we do with these characters, I'm going to just quit here. One of the things that we do with these characters is replace our character when they die. So here I've got a little simple character, the plumber, and as I've set this up so that when I press the escape key, he dies and he turns into a ragdoll. And so my death script has a public game object ragdoll. This is where we insert the ragdoll of the plumber. And here in the update function, I'm just watching for the escape key to be pressed, at which point I call the function die. And I've written it this way because later we're going to set our character up to count points, and when their health is too low, they're going to die. So in the die function, what we're doing here, we're testing to make sure, first of all, that somebody has bothered to insert a ragdoll in the public inspector. So if we haven't got one, it's not going to do anything. And then I'm going to instantiate a ragdoll. I'm going to make that prefab appear in the world, and it's going to appear at the player's position and with the player's rotation. That's the transform here is the object to which the script is attached, and that's our player. I'm going to catch the velocity of the player, and there are two possible ways that characters are controlled. One is through the character controller. That was that thing that I mentioned that lets you climb up steps and go up hills. And we can access the character controller and catch its velocity. Other characters are controlled by their rigid body. And so we can alternatively catch the rigid body's velocity. And I'm just going to add a little bit of upward velocity and a little bit of forward velocity. The up vector is in the Y direction, and the forward direction is in the Z direction. And I'm going to add a little bit to that velocity that I caught from rigid body or character controller. Then there's this CopyTransformRecurse. And let me show you what happens if we don't use that. So here's instantiation without the copy. And my little character, I'm going to run them forward and press the escape key. And what you saw there is that it came into existence in the T-pose. It came into existence in the form, leave the cat alone. Hey, Liba. Sorry, my dog is chasing my cat around the house. Liba, stop it. So it came into existence in the T-pose. So this CopyTransformRecurse is kind of a tricky thing that's going to work its way down that tree of objects, finding different pieces and setting their orientation to match what the character was doing when the character died. And so this looks like this. We've got a source and destination, which initially is the transform, that's our living player, and the dead transform, which is the ragdoll that we just instantiated. And I'm gonna get the rigid body, and if it has a rigid body, if destination is not null, I'm going to set the destination's velocity to that velocity that I just caught from the rigid body or the character controller. I'm going to turn on gravity, and I'm going to set its position and rotation to be the source's position and rotation. So this is going to match up the different pieces in the character as it traverses down the tree. So that did it to the topmost. And now we're going to go through all the children in the destination. The destination has children. So I'm going to, for each child in destination, I'm going to test its name and look for a child name that matches the current source. And when I find that, I'm going to call CopyTransformRecurse again, now with the current source and the child that I found, setting its velocity. And so this goes down through the tree, through all the children of each of the different destinations. And now when my character comes into existence, I'll run here and escape. And that time it didn't, the ragdoll was set in the same configuration as the character. It's a subtle thing, but it's kind of important to be immersive. If your ragdoll always comes in T-pose, it's kind of weird. So that's replacing our character when they die. Whoops. So I think I deleted it. Did I delete it? I did. So there's one other little piece there that I deleted. Let me get back. One other little piece that I deleted there, or turned it off. And that's this little piece here. When I'm done with the copy recursion, I need to turn off the player. And I do this by setting its game object to set active false. And that disappears my player, makes it no longer controllable, no longer active. It disappears from the scene. I believe that's this right here, where it's now turned gray because it's no longer active. It's no longer an active object. Its little tag here is turned off. Here's an interesting bug, which of course could be a feature. I forgot to do that delete. And so let me move my character up to the top of the hill here, because this takes some space. And I'll stand here at the top of the hill and I'll press escape. And because I'm not deleting my character, it just continues to make more and more of these ragdolls. And so I don't know what you do with this. This is your ragdoll weapon, where you fling copies of yourself out into the world and do something with them. This is also an interesting stress test for the physics system here, since all of those ragdolls are physics objects with rigid bodies. And so you could see that the frame rate has gone down quite a bit. Interestingly, if I wait long enough, these things all go to sleep and the frame rate goes back up again. But that's kind of interesting. So that's character joints. A, they're hard to work with. They're very non-intuitive. You have to know a lot about anatomy to make them effectively. B, they're easy to use because we have a tool that wires up a humanoid form for us without us having to do any thinking. Now, the last joint is the configurable joint. It's kind of the basis of all the other joints. All the other joints, I'm sure, are just special cases of the configurable joint. And it has a lot of properties. Some of them are similar to simpler joints, things like the connected object, the anchor. It has dominant and secondary axes like the character joint with its twist, swing 1 and swing 2, but there are a lot more properties. Among them are the X, Y, and Z motions that can either be locked, they won't move, they'll be limited, in which case they use a linear limit, or they can be free. And we have the same settings for the angular X, Y, and Z motion. So we have a lot of control over how our joint is connected to the world. It can be fixed with X, Y, and Z, or it can be constrained not to spin with angular X, Y, and Z. So lots of control. The limits are specified with a plus minus range. Limit of 45 would go from minus 45 to plus 45. We have this bounciness for how it behaves when it hits the limit. And we have springs and dampers that control how it behaves when it hits those limits. And we have the same thing for the angular limits on both the dominant axes and the secondary axes. We have target positions and target velocities, and we have various kinds of motors that will drive it to either its target position or its target velocity. We have the position spring that if position is selected, it'll drag it to that position. If we have the velocity included, it will apply a force to get it to that position. And we can also target specific orientations that are defined by quaternions. We'll talk about them later, or target angular velocities, rotation about the different axes. And we have a number of different drive modes, each one that acts a little differently, things like the slurp drive that treats all axes the same. So, and of course, brake force and torque that let us break apart whatever our object is. So given that, the configurable joint can make some really interesting objects with some very simple settings. For instance, here I have an example of a prismatic joint. This is a joint that only slides along one axis, and it has some limits. It's like a drawer or a sliding door. It can go out so far and it can go in so far, but it only moves in one direction along a specific axis. So I made a cube, I gave it a nominal mass, I added the configurable joint, and I set the Z motion to be limited, and all the other motions were locked. I didn't change any of the other settings. Everything else down through that long list of options, just leave it alone. And on this, for the linear limit, I set it to 1, so it could move 1 unit, and I set the spring and damper to various values. And with that, I now have this prismatic joint that I can slide around with my spring joint, little drag object, and I can move it around, and I have this sliding door or whatever it is that I can use. Now, another example is the Blob Shadow. And if you remember back when we were playing with lights, I showed you the projector, which made a blob shadow. It was this projector up above our object that cast a shadow down on the world. And I never really put one on the ball because this happens when you put it on a ball. The projector rolls with the ball and the shadow is cast off in odd directions that don't make any sense. But with the configurable joint, we can fix that problem. And so here, in this case, I have this sort of empty game object at the top of my hierarchy that has nothing but a rigid body in it. It has a rigid body and a configurable joint. And the configurable joint has locked X, Y, and Z motion and free angular motion. And everything else is just left alone. I don't bother with anything else. And then as children of this object, I have the actual sphere that I want to have bounce around. And it's set, it's a child, and it's set at 0, 0, 0. So it's exactly the same location as the parent object, which is someplace in the world. And it's the connected body of the configurable joint. So this joint is connected to this sphere, but its X, Y, and Z position are rigid relative to it, but its angular motion is free. And then still inside here, as children of this thing, I've got the projector that's set 3 units up above and is pointed down. And now when this thing runs, the projector now stays on top of the ball, even as it bounces and rolls around. And so that little blob shadow is nicely pointed down and nicely shown on the ground underneath it. So that's a nice fix for our blob shadow, because while it was okay with the character, it was not okay with an object that rolled around. So that's the configurable joint, which has many more options, but with a few simple settings, you can do some really fancy stuff. So I'm going to entertain questions here at this point. And I want to move on rapidly to the next thing. I think I showed you, let me open a new game object here. Making a car. Back when we were doing colliders, I mentioned the wheel collider, but I didn't do anything with it because I wanted to focus on the making of a car. And so with our wheel collider, we have this wheel collider that has a lot of properties. And let me start this running here so that we can see the wheel collider kind of bounce around. And the wheel collider has a spring in it. It has a suspension system in it, and it has a wheel that contacts the ground underneath it and produces forces and torques. And in scripting, we can set this up so that I can steer the wheel and I can apply forces and torques and make the wheel move. And you notice as this wheel moves, it doesn't change orientation. The wheel collider in its connection to this little unicycle is always with the Y direction up, whoops, is always with the Y direction up. And even though the gizmo there is turning, the wheel collider itself is not. It always has its Y direction up and its Z direction forward. The blue axis is the forward direction of my wheel collider. And we've got things like the radius of the wheel, the mass of the wheel, the damping rate. So this is kind of the springiness of our little wheel. We have various settings for the suspension distance. If I fiddle with this, you can see that the orange line is getting longer or shorter. That is making the suspension bigger or shorter. And there's also the force application point, which is that little dot down here at the bottom. And when it's at 0, the force is applied at the ground. If I make that 0.5 or 1, it moves it up, and we'll see that can affect the way things handle later. And then I have the suspension spring, how strong this spring is, and it has a damper as well as a target position where that spring wants to go. Sorry. So the wheel joint is really fancy and allows us to do a lot of cool stuff. It calculates friction forward and sideways. It has this fancy suspension with bouncy springs and dampers. But most of the stuff we access from scripting, things like the application of the motor's torque and the steering angle. This is all done in scripting. We have some read-only things that we can access from scripting, whether the tire is touching the ground and how many RPMs it's spinning and others. There's lots of stuff we can do. What it doesn't do is spin the visible wheel. The visible wheel is not what you put the collider on. In fact, what we usually do is put the visible wheel as a child of the wheel collider. And in scripting, we're going to set its orientation to match the orientation of the wheel. And we have to do that in scripting. There's no way to do it other than that. Other properties, its center where it is, the radius. The radius generally should be bigger than the visible wheel, because if the visible wheel has a collider, it's going to get in the way of the wheel collider touching the ground. And but you do need a physical wheel to actually push things around, since the wheel collider can only touch the ground underneath it. It can't push things around. Suspension distance, spring strength, and the friction. Now, the friction of our wheel defines how the force is generated when we apply a torque. And it's done through the specification of these 2 points, the extremum slip and value and the asymptotic slip and value. And that is this curve right here. Here's the extremum slip and value and the asymptotic slip and value. Now, what I mean by slip is how much sliding our wheel is doing relative to its contact to the ground. A wheel doesn't generate any torque unless it's sliding, unless it's slipping. And so when it's generating 0 slip, and this is the difference in motion between it and the ground, it makes 0 force. But as the tire spins, it makes more and more force until it reaches this extremum value. And as it slips more and more, it goes back down to this asymptote value. And any slipping above that just produces a uniform force. So and we have this setting both for the forward friction, the wheel driving the car forward, but we also have identical settings for the sideward friction, how much the car is going to slide sideways and drift. And all of this is set here in the inspector of our little wheel. I have slip at 0.4, extremum at 1, asymptote at 0.8, asymptote at 0.5. Stiffness is just kind of a setting that you can automatically multiply everything here by this stiffness. If I make this 2, it doubles everything and makes your car have more friction. So that's our little curve. And so we're going to make a car. And here's my little car. Whoops, not that one. Here's my little car. And at the root of my car, I'm going to have a rigid body. It has its transform and its rigid body, but that's all it has. Well, it has the car controller that we'll talk about in a minute. Cars are heavy. The default settings that come up with a wheel collider are designed for a car that weighs 1,000 or 1,500 kilograms. So right away, you want to set your car mass up to 1,500. There's drag and angular drag that we can leave alone. And I'm gonna, for convenience, well, I have a little collider here, a little cube that is the visible car. That's this red cube here. I have its box collider turned off. You can turn it on later, but it affects the handling. And then I have an empty game object, just a transform set at 0, 0, 0. That is my container for the wheels. It's convenient to have kind of a container for the wheels. And so I've got each of these different wheels. Here, this kind of walks you through the setup of the wheels because you want the wheels to kind of all be identical. So we make one wheel, set its position, give it a name, front right, then make a copy of it, duplicate it, move it over to the other side of the car, make it front left, and then move the 2 of them back to -1 and rename them left rear and right rear. And once we do that, and we can just leave all the default settings alone, but I think I've probably fiddled with these because I like a nice bouncy car to fool around with. And so now we have our car sitting nicely on the road with the springs kind of compressed and the thing all settled down here and behaving like a little car. But until I put a script on it, nothing happens. So I'm going to add this control script to it. And it's simple car controller 1. I wanted to use a list here, and so I had to add collections and collections generic. These are the modules that have the list in it. And I have a list of axle info. Axle infos is the name of the list, and axle info is the thing that's in the list. And down here is a serializable class, axle info, that has a left and right wheel and Booleans for whether it has a motor and whether it's steering or not. And serializable means that I can put it in the inspector and see it. So my car root here has this simple car that has axle info in the inspector, and I'm specifying that I have 2 axle infos, and I've loaded up the left rear, right rear, which I'm going to make a motor, and the left front, right front, which I'm going to make steering. And I've got a maximum torque and a maximum steering angle that I'm going to use to drive my car around. So having done that, here's the max torque and steering angle. Having done that, in the fixed update, and you saw the update function sometime before, and the update function happens every frame of the game. But the fixed update is where we do physics, where we apply forces. And the reason for that is the fixed update happens at regular intervals. It happens at every 0.2 seconds. So 60 times a second. Hi, what do you want? Sorry, that's my dog. What I'm going to do here is I'm going to use a for each and go through that array or that list of axle infos, which in my setup here has 2 axles in it. And I'm going to, so for each axle info in axle infos, I'm going to test if it's set to steer, in which case I'm going to set the left and right wheel's steer angle to that steering angle. And I'm going to set the motor to that, if it has a motor on it, I'll set the motor to the torque. And those values I get from the input axes. Vertical and horizontal input axes, we'll see, are very useful. They are the W, A, S, and D keys, and they're the up, down, left, and right arrows. Vertical is up, down, W and S. Horizontal is A, D, right and left arrows. And these get axes do magical things. When they're not pressed, they're 0. When the up arrow is pressed, the vertical axis goes to 1. If the right arrow is pressed, the horizontal axis goes to 1. If the left arrow is pressed, it goes to -1. So these get axes go to ±1, and they don't do it instantly. They do it over some amount of time. So this is not a binary 0-1 thing. It's a 0 increasing to 1, and then when you release it, it's a 1 decreasing back to 0 again. So, and that's a tunable parameter that you can set. So that's all I need to do to set up my car so that I can now drive it around the world. And I'm doing up arrow, and that's applying a torque, and I'm doing right and left arrow, and that's steering my car around. And you can see the little wheel colliders because I have gizmos turned on here. You can see the wheel colliders, but we have no visible wheels here. Now, to have a visible wheel, I have to do something. And one of the ways of doing this is to add a visible wheel to my car. So here I've added as children of the car of the wheels a flattened cylinder. And the flattened cylinder, here I'm in wireframe and shading here, the flattened cylinder looks like a wheel. And so first time I did this, I very happily put the wheel on there. It has its own collider, a capsule collider that I've shrunk down so that it's not that big. It does stick out of the ends a little bit, but there's a problem. Here's the orientation of the wheel collider. And remember, I said its Y direction has to be up and its Z direction is forward. And here's the cylinder. The cylinder's Y axis is along the axis of the cylinder. And so when I flattened it down to make it into a wheel, its Y axis is pointing off to the side. Now, what we're going to do over here is set the visible wheel's position and rotation to be the collider's get world pose. So I've got this little function, apply local position to visuals, that takes a specific wheel collider, finds its child, and calls the get world pose, which outputs a position and a rotation, and I assign that to the visible wheel. So this is going to make my visible wheel have the same position and rotation as my collider. And we're going to put that in the for each here, where after I've set the steering and motor, I'm going to apply local position to visuals of the left wheel and right wheel. So here's what happens when we do this. Our wheels turn into paddles, and because the cylinder's vertical axis is in the Y direction, and so my cylinders are now not right. They're wrong. I'll fix this next time, Monday. I'll show you the fix here quickly is to put an object in for the wheel that has the right orientation. So this has the proper Y direction up and Z direction forward. And it has itself a child flattened cylinder that is oriented to line up with it. So this is the thing that's going to be oriented. And so in this case, my wheel is going to work properly, and I'm able to drive around the scene, and my visible wheels now match what they're supposed to. And I'll come back and do much more with cars next time. So let me stop sharing here and entertain any questions. I went a little bit over, I apologize. Don't forget to put your name in chat if you haven't already. And I'm sorry if you asked any questions in chat because I can't see it. Once you create the Wagdoll, where does it store in your editor? I can create a new one, but not sure where it ends up. If you're still here, Brooker, are you still here?
Yes.
Yes. Okay. So after I created the Ragdoll, I just make it a prefab. Just drag it into your prefab folder, and it's then a prefab, and then you can make as many copies of it as you want. And you remember at the beginning there, I unpacked it from its original prefab, the FBX model of the character. I unpacked it, and that turned it black. And by dragging it back into a prefabs folder, that makes it a prefab, and then it's saved. Does that answer your question?
Yeah, I had just made it and then saved it. And when I ran my game, it had the ragdoll in it, but I didn't have it as a prefab, so I couldn't like open it back up to edit it again.
Oh, well, you don't have to edit it again. If it's still there in the scene, you can still prefab that. If you have a ragdoll in a scene, even if it's not a prefab, if you say
Then I can take it from the
still
scene.
there. But
Okay.
take that prefab from that scene and drop it into a prefab folder in the project view, and then it will be available for you to do things with. Okay.
Okay. Yes, thank you.